Hello everyone, and welcome to the last video on rational numbers for now anyway. This one is a technical skills video on the topic of expressions that have rational numbers in them. Now, just a reminder that an expression is a meaningful sequence of numbers, operations, and quantity symbols. The definition has not changed. It's the same as the one that we had for natural numbers and also integers. Except that now that we know about rational numbers, numbers can include rational numbers. So an expression can include natural numbers, integers, rational numbers, and so on. And of course, operations such as addition, subtraction, multiplication, division, and quantity symbols are also possible. Such as, let's say, m for mass, or m for the value of mass, T for the value of temperature, and so on. Examples of expressions. An expression could be as simple as just a number, like 4. Or it could be a simple sum, such as -8 plus 3. It could be a bit more involved. It could be a one-term expression that has two factors, such as -3 multiplied by the bracket. And the second factor, which is a bracket, which is a set of brackets, includes 2 plus 3 times 4. So this one is still meaningful. We know what needs to be done. We need to multiply 3 by 4, add 2 to it, and then once we've worked out the brackets, we multiply by -3. So this is what we mean by meaningful. It means that it's clear what should be done. We can carry out the operations as they are written, and then in the end we'll come up with an answer, which is a number. And now here's an expression that has rational numbers in it. 2/3 plus 2/5 times 1/6. And as I did introduce the analysis synthesis technique back in natural numbers when we studied expressions that involved natural numbers, and later on we extended the technique to deal with expressions that have integers in them. And the process or the technique remains unchanged. It's still identical to the one that we had for integers. And just to remind you of it, to evaluate an expression involving rational numbers, stage 1 is to analyze. So we break it down into its logical components, and we break those logical components into their logical components until we arrive at the smallest pieces, which are the numbers themselves. We begin by breaking the expression into terms using additions and subtractions outside brackets. Then each term breaks into factors, which are entities within terms that are multiplied by each other. And if there is a need, we break each factor further, if needed, of course, such as if you have brackets, and inside brackets you have the sum of two products, you can break it up into terms and work those out. Once we have broken the expression down into its logical components, this gives us an insight as to how it is put together. And then we go the other way and we synthesize, which means we start with the factors and we work out the factors. Then we evaluate the terms by multiplying the factors. Just as the case with integers, do the sign followed by magnitude. Makes it much easier. And then evaluate the expression by adding and subtracting the terms. And again, sign followed by magnitude. Okay, it's time now to take a look at a few examples. And in the examples that are coming up, I will start with expressions that have only addition and subtraction in them. Then we'll take a look at expressions that have only multiplications and divisions in them. And then we'll take a look at the case when all 4 basic operations are present. Following that, we'll end the talk by looking at expressions that involve complex fractions. Okay, so examples for addition and subtraction. Problem number 1, 2/3 plus 4/5 minus 3/4 plus 1/2. For this kind of a problem, as I indicated in the video on addition and subtraction of rationals, you need only one fraction line. This makes it much more efficient, and later on with algebra helps reduce the amount of writing and also overuse of brackets. So we put one fraction line, noting that we're going to add 4 numbers on the top. Make sure it's long enough to give you enough space. Better for it to be a bit longer than a bit shorter. And then we find the least common denominator. How you find the least common denominator is something that I discussed in one of the previous videos on, it was the structure, I think, of rational numbers. No, actually it was on order. Yes, ordering rational numbers. And I invite you to take a look at that video on the detail as to how we find the least common denominator. Now, I assume that you know how to find the least common denominator for these numbers. I'll give you another tip on this process. When I take a look at the numbers that we have, I notice that 2 goes into 4 evenly. And so I can ignore the 2, because if I find a number that's divisible by 4, it will be divisible by 2. 3, 5, and 4 have nothing in common. Whatever goes into 3 doesn't go into 5 or 4. And whatever goes into 4 doesn't go into 5 and 3, and the same thing for 5. And in such a case, you'll end up, the least common denominator ends up being the product of the 3. So we can just multiply 3 by 5 by 4 to find the least common denominator, and that would be 60. You can also use the chart as I explained in the video on ordering rational numbers. Okay, so we've got 60, and then in sequence we divide by the bottom, multiply by the top. Again, this was discussed in the video on addition and subtraction. You notice that I refer you back to these videos, and that's the case. That's going to be the case for this video. This video does require that you have watched the previous videos. There are many techniques in terms of how to reduce, how to convert from mixed number to improper fraction to mixed number, and how to find the least common denominator, and so on. And to make sure that this video doesn't get too long, I'll refer you back to those videos on these fundamental skills. Okay, so once we have the 60, in sequence we divide by the bottom, multiply by the top. 60 divided by 3 is 20. 20 divided by 2, 40. And then plus 60 divided by 5 is 12, and 12 times 4 is 48. Minus 60 divided by 4 is 15. 15 times 3, 45. And then plus 60 divided by 2 is 30. 30 times 1, 30. Now we add and subtract the top to end up with a balance of 73 pieces, each of which is 1/60th. And we can convert this to a mixed number to get 1 and 13 over 60. Okay, problem number 2. 2.5 plus 6 minus 1/4 minus 3 2/3. Now we've got mixed numbers and also natural numbers. I think when you have more than 2 of these entities, it's usually, there are exceptions, but it's usually just easiest, especially if the whole parts of the mixed numbers are small, to convert them to improper fractions and then proceed. So we convert 2 and 1/2 to 5/2. That's 2 times 2, 4, plus 1, 5. And then plus 6 over 1, minus 1/4, minus, and then we have 3 times 3, 9, plus 2, 11. So we get 11/3. For the least common denominator now, again I notice that 2 goes evenly into 4, so I can ignore 2. 4 and 3 have nothing in common, it will be 12. And then in sequence we divide by the bottom, multiply by the top. 12 divided by 2, 6. 6 times 5, 30. Plus 12 divided by 1, 12. Times 6, 72. Then minus 12 divided by 4, 3. 3 times 1, 3. Then again minus 12 divided by 3, 4. 4 times 11, 44. And we end up with 55/12, which is 4 and 7/12. Okay, so these are, this is how you can deal with expressions that have only addition, that only involve addition and subtraction of rational numbers. Now the next example set will focus on problems where we have chain multiplication division, so only multiplication and division are present. Okay, so now we have examples for multiplication and division. Problem number 3, we have -4 2/3 divided by 7/5 times 6 times -1 over -18. So I have pretty much everything in there now. I've got mixed numbers, natural numbers, proper fraction, improper fraction, negative numbers, and so on. And so I hope you remember to do the sign first. There are in total 3 negatives, and that makes the answer negative. And now from now on, we can ignore the negative signs. Now we convert 4 2/3 to an improper fraction. 3 times 4, 12, plus 2, 14, and we get 14/3. Then we have divide by 7/5, multiply by 6/1, times 1 over 18. You notice that I didn't write the negatives down because we've already taken care of the sign. This makes things a lot easier, by the way. Keeping all these negatives along the way and working with them or dealing with them when you get to them can become pretty annoying when you have many of them. Also, some people choose to deal with division at the same time by converting it into multiplication by 5/7. If you choose to do that, please make sure that you practice enough so you don't make a mistake, because I often see something go wrong when people do this. Okay, so now division by 7/5 becomes multiplication by 5/7. Now we have chain multiplication, and we reduce what we can. And now I leave that to you to check the reduction if you like, but in the end you'll end up with -10/9, which is -1 and 1/9. Problem number 4, -2 over -5 divided by 1 3/5 times -6 divided by -2. And now we have 4 negatives, so the answer will be positive, and we can just ignore the signs. Initial fraction is 2/5 divided by we convert 1 3/5 to an improper fraction to get 8/5. Then we multiply by 6/1 and divide by 2/1. You see, once we take care of the signs, it becomes much simpler. Now, division by 8/5 will turn into multiplication by 5/8. Then we have times 6/1. And then division by 2/1 turns into multiplication by 1/2. And we are back to chain multiplication. We reduce what we can. And in fact, you see, you can even do this in your head. The numbers are so simple. 2 and 2 cancel out. We get 1 and 1. So let's ignore them. Same thing for 5 and 5. 6 and 8. 2 goes in 3 times. 2 goes in 4 times. And you get 3/4. Okay, so that's the end of the examples for chain multiplication and division. Now we will take a look at problems where all 4 basic operations, addition, subtraction, multiplication, and division, are present. And here we have problem number 5. 2/3 plus 1/2 times 3/4 minus 1/10. Now, following the algorithm that we had, we break the expression into terms. Terms, you find them using additions and subtractions outside any brackets that may be present. 2/3 is one term. And then from addition to subtraction, you have the next term, which is 1/2 times 3/4. And this is followed by 1/10. So the intention is that we should work out these terms and then add and subtract them as indicated. Term number 1 is of course done. It's 2/3, so we're going to leave it as 2/3. Term number 2, we can finish the multiplication. You notice that nothing reduces, and so we multiply the top to get 3 and we multiply the bottom to get 8, and then subtract 1/10. Now we need the least common denominator for chain addition subtraction. And in this case, we find that we get actually a large number for such small ones, like 3, 8, and 10. Sometimes that happens, by the way. When there are not a lot of commonalities between the numbers, like there is a 5 in 10 that makes it large. You should expect a large number even for small values to begin with. Now 120 divided by 3 is 40, and 40 times 2 is 80. And then 120 divided by 8 is 15, multiplied by 3, 45. And 120 divided by 10 is 12, multiplied by 1, you get 12. So the answer is 113 over 120. Problem 6. 3/4 divided by 2/3, that's term number 1, plus 1/4 times 2/3 times 1/3, that's term number 2, plus 1/2. We work out each term and then we add and subtract them. Now, one advantage of the analysis synthesis technique over BEDMAS right now is that I don't have to wait. The second one doesn't have to wait for the first one to finish. We can work on multiple terms at the same time. With the first one, we switch from division by 2/3 to multiplication by 3/2. With the second one, we can finish this. 2 and 4 reduce to 1 and 2. And we have 2 times 3, 6 times 3, 18. And then plus 1/2. Now we finish this one, nothing reduces, we get 9/8. Then plus 1 over 18, plus 1/2. Least common denominator turns out to be 72. And in sequence, we divide by the bottom and multiply by the top. 72 divided by 8 is 9. 9 times 9, 81. 72 divided by 18 is 4. 4 times 1, 4. And 72 divided by 2 is 36. Multiplied by 1, 36. We get 121 over 72, which is 1 and 49 over 72. Problem 7. Now this time we've got brackets. And again, you use additions and subtractions outside brackets, initially anyway. Later on, when the time comes for you to work out the brackets, that's the time to go in and then break the expression within brackets into terms. But initially, you imagine that you can't even see what's inside brackets. So the addition here tells us that 3/4 times 2/3 is 1 term. Then there is a subtraction here. This one doesn't count because it's inside brackets. This subtraction tells us that the next term starts here with 1/2 and ends at the end of the bracket, where the bracket closes. And 3/8 is a term on its own. So we have the following. Okay, we work out term number 1. 3 and 3 reduce to 1s, so we can ignore them. 2 and 4 become 1 and 2, so we have 1/2. Now, the second term has 2 factors. Factor number 1 is 1/2. Factor number 2 are the brackets. These are the brackets. And we need to work out both factors and then we can multiply them. Factor number 1 is already known. It's just 1/2. For factor number 2, we have 2/3. Now, we know that factor number 2, which is brackets, itself breaks into 2 terms now. 2/3 is 1, and then we have 3/5 times 1/3. We need to work out the terms and then do the subtraction. The first term is 2/3. The second one, we work it out, the 3's reduce, and we get 1/5. And then subtract 3/8. Terms 1 and 3 are done. The middle term still needs to be worked out. And so term number 1 is 1/2. For term number 2, we have 1/2, and then we multiply this by least common denominator is 15. And then in sequence, we divide by the bottom, multiply by the top. 15 divided by 3, 5. 5 times 2, 10. Minus, then 15 divided by 5, 3, times 1, 3. And then minus 3/8. Now I switched from brackets to multiplication because here you need the brackets because there are 2 terms. You need to work this out, then multiply by 1/2. Whereas here the fraction is seen as 1 factor on its own. So here brackets are 1 factor and here the fraction is 1 factor. And so you don't need to or you have the option of dropping the brackets. Either you use brackets, you continue to keep brackets, that's fine as well, or you switch to the notation for times if what follows is only one term. All right, we finished the top, 10 minus 3, and that gives us 1/2 plus 1/2 times 7 over 15 minus 3/8. One more thing to do before this middle term is done. Nothing reduces, and so we multiply the top numbers to get 7 and the bottom numbers to get 30 minus 3/8. Least common denominator is 120, and then in sequence we divide by the bottom, multiply by the top. 120 divided by 260 times 160. 120 divided by 30 is 4. 4 times 7, 28. And 120 divided by 8 is 15. 15 times 3, 45. We arrive at 43 over 120. Problem 8. Now we've got a lot of negative numbers, and this is where dealing with your negatives first becomes really handy. You'll notice that this problem, which looks like it will never ever finish, will actually turn into a very simple problem in one step. Let's take a look at how. First, we identify the terms. The additions, in this case there are only subtractions outside brackets, and we don't have brackets, indicate where the terms start or end. Term number 1, work out the sign. For each term, work out the sign, then work out the magnitude. Sign-wise, it's going to be negative. Now we ignore the signs. The 5's cancel out, we get 2/3. Now for the next one, just like with integers, there is nothing new here in terms of how to work with the sign, by the way. It's identical to how we dealt with the signs with integers. I have 1, this one counts as well. Remember, subtraction goes with the term that follows, and you can as a shortcut, you can consider this to be a negative sign as well when you count the negatives. So there are 1, 2, 3, 4 negatives. That makes it plus. Now the 4's cancel out, and then we get 1 times 1 divided by 3 times 2, so that's 1 over 6. Now here we have 2 negatives, that makes it a plus, and then 1/2. You see how so much complexity is gone in one step. Now this is chain addition subtraction, and least common denominator is 6. When you work with a leading negative, it always is easiest to associate the negative to the top. In an earlier video, I did discuss that you can put the negative sign on the top or the bottom or on the side, on the left side, and it's all the same thing. When you do calculations, it's usually easier if you put the negative on the top. In your mind's eye, you can associate negative to 2. So we have 6 divided by 3, 2, times negative 2, negative 4. And then plus 6 divided by 6, 1, times 1, 1. And then plus 6 divided by 2, 3, times 1, 3. Negative 4 plus 1 is negative 3, and negative 3 plus 3 is 0. So we end up with 0 over 6, which is 0. Okay, so that's how you deal with expressions when you have multiple terms, and you work out the terms, and then you work out the factors, and then you work out the terms, and then you add and subtract them to work out the expression. Now, one more topic for this video, and that's expressions that involve complex fractions. All right, problem number 9. So we have seen complex fractions earlier in the video on multiplication and division of rationals. But there we didn't have cases where we have to do something on the top and the bottom of the complex fraction. It seemed like everything on the top was done and we had just one fraction, and then everything down in the denominator was also done and we had one fraction. But there are cases when you have to actually do some work before you can find out what's on the top and what's on the bottom. And then you can take the shortcut that I talked about in the previous video on multiplication and division of rationals. So here we need to work at the top and we need to work at the bottom. And we start to work in each step. We do two things. Take one step on the top, one step down. Okay, good practice, good writing style requires that you write the main division line first, and then on the top we'll take one step. we need to find the least common denominator, which is 12. Then in sequence, 12 divided by 3, 4, times 2, 8, plus 12 divided by 4, 3, times 1, 3. Now we take a look at what we have down here. And again, it's a subtraction, so we need the least common denominator. That's a 10. Then in sequence, 10 divided by 2, 5. 5 times 1, 5. Then we subtract 10 divided by 5, 2, times 3, 6. Alright, now we finish the top and we get 11 twelfths. Then we finish the bottom. 5 minus 6 is negative 1. So negative 1 over 10. Now, so this is how we work out complex fractions. We do what needs to be done on the top, we do what needs to be done in the denominator, and then once both the top and the bottom have been reduced to just one fraction, then we take the shortcut that says you can multiply the top number and the bottom number that goes on top and multiply the middle two and they go down. Don't forget to work out the sign first. So it's going to be negative because there is only one negative sign, and then we have 11 times 10 on top, and then 12 times 1 down. You should reduce 12 and 10, 2 goes into both, and you end up with negative 55 over 6, which is negative 9 and 1/6. And I believe this is the last problem. Number 10. Now on the top of this complex fraction we just have 2, so the top is pretty easy. In fact, to turn it into one fraction like 11 over 12 that we had here, we just turn this into an improper fraction, 2 over 1. Down here though, we have to take a few steps. Alright, let's see what we get. So this is equal to, on the top we have 2 over 1. Now down here we write 5 as 5 over 1. And noticing that we have two terms, term number 1 is 3/4, term number 2 is 1/2 times 5 over 1. We finish term number 2 and we get 5 over 2. So this is equal to 2 over 1 over 3/4 plus that becomes 5 over 2. Now we need the least common denominator, and now we have 4. Then you divide 4 by 4 to get 1. 1 times 3, 3. And 4 divided by 2 is 2 times 5, 10. Simplify the denominator to get 2 over 1 over 13/4. Now that the top and the bottom have been reduced to one fraction each, we take the shortcut. 2 times 4 goes on top, and 1 times 13 goes down. Nothing reduces, and we get 8 over 13. Okay everyone, so thank you very much again for watching this video, and we are done for now with the topic of rational numbers. And in the next video I will go back to the problem solving skills component of the program, and I will talk about how one goes about modeling linear equations. Take care everyone.